This one was disastrously done. Okay, let's have a look. You start with this absolute value graph, right? That's f of x. And then you get asked to graph this. Now, admittedly, it's a little bit weird having the absolute values over there on this side. We're not used to that. But it's still not that hard to tackle if you just go about it in a methodical way. Here's where I begin. Absolute value of y equals f of x. Before pen goes to paper on the graph, you already know right here there is a restriction. Right here. What is the restriction that's implied by this line? Good, good, good. If this is an absolute value, right, what's over here must be positive, right? F of x must be greater than 0, right? In other words, if f of x is less than 0, there's nothing you can put into y that satisfies that, right? So here's f of x, right? This is y equals f of x. And there are some parts of this curve where f of x is not positive, namely these guys in here, right? So I can't take anything from there and put it into this. There's nothing that's going to satisfy that, right? So immediately, I just forget about this part. Okay? I can ignore it because no part of that graph is going to translate to the one I'm doing now. Okay? So now I'm left with this. Okay? Now, to come back to this, the easiest way to think about it is, well, what does absolute value mean? And when you were first introduced to absolute value, like last year, year before that, you learn a few definitions. Right? You learn, for instance, you just take the positive value. That's one definition. Okay? Another definition is you take the distance. That's another definition. The most technical definition, which turns out to be the most helpful in this context, is that if I've got this, right, I'll write it around the other way to make it a bit clearer. F of x equals the absolute value of y, right? What this means is that f of x is equal to two different things at two different times. Okay? It's equal to y sometimes, and other times it's equal to negative y. Okay? Now you tell me, obviously it's not domain, it's range. In what range, what values of y is this case true? When y is what? It's when y is positive or equal to 0. 0 actually kind of doesn't matter because it's going to be the same outcomes. So I tend to put the equality there even though it's not a big deal. Okay? So it's equal to y when y is greater than or equal to 0. It's equal to negative y everywhere else, namely when y is negative. Okay, so now you take this. Okay, I'm running out of space. Put it over, I'll put it in here. You've got these two different branches, if you like, okay? So you've got, in some times, f of x equals y. That's when y is greater than or equal to 0. Okay, so there's one case. And then the other case is when y is less than 0, you've got this. Now this is still a little bit weird, but I only have to do one more thing to make sense of it, okay? Let's come up to here, let's write this around the normal way that we're used to, okay? So when y is positive, it's just equal to the original graph, which is what I have here. This was the original graph, I just dropped some bits off it, okay? Here, I'll just make y the subject, that's all I need to do. Y equals negative f of x. So when y is less than 0, in other words, down here in the graph, what's it going to look like? And the answer is it's going to look like that, right? So that's easy enough. All you have to do is flip it, reflect it across the x-axis. So you get this. This branch, or these branches down here, these are negative f of x. And that's it. That's all you have to do, okay? So admittedly, even though the graph looks so simple, okay, there were lots of people who had, stuff in here, right? Because you missed the restriction. Other people who had, they just had the top half because they thought, they applied the absolute value to the right-hand side rather than the left-hand side, okay? So it's a very, very simple graph, testing if you understand these concepts.